Okay. Hi friends, in this particular video, I am giving you a brief idea about the addressing modes of 8086. Let us see. Right. So let us see what is addressing mode. So addressing mode indicates the number of ways processor can access the data is referred as addressing mode. Nothing but how many ways processor can access the data is referred as addressing mode. So for all those addressing mode syntax is only one. Mnemonic is move, destination operand comma source operand, destination operand comma source operand. So every time the data is always transferred from source to destination only. So mnemonic must be move for all addressing modes. Let us see what are the various types of addressing modes. So addressing modes nothing but the number of ways processor can access the data is referred as addressing mode. Let us see first immediate addressing mode. So in this particular addressing mode, the source operand and must be the source operand must be either 8-bit data or 16-bit data, but destination operand must be registered. So in immediate addressing mode, the source operand must be either 8-bit data or 16-bit data, but destination operand must be registered. Let us see example. For example, I am writing like this: move al comma ath. So let us see what the meaning of this instruction here. 80 is the 8-bit data and this data is moved to 8-bit register AL. So after executing this instruction, the register AL now contains data ATH. Here in this particular example, the source operand is 8-bit data. Let us see another example. For example, move SI comma 3000H. So in this example, the size of source operand is 3000H. So it is a 16-bit data. SI is a 16-bit register. So if you execute this instruction, the register SI receiving 3000H data directly. So no memory, no register is required to receive data. So in these two examples, straight away we are transmitting 8-bit data here, whereas here we are transmitting 16-bit data. Immediately no other register or no other memory is required to transmit data. That's why this addressing mode is called as immediate addressing mode. Immediately we are transmitting either 8-bit data or 16-bit data directly to one destination register. Depending on the size of the data, we are using 8-bit register or 16-bit register. Because data is 16-bit source data, that's why register size is also 16. Coming to direct addressing mode. Let us see what is direct addressing mode. See, in direct addressing mode, the source operand and the destination operand if you take. So one must be register, other must be memory. So in direct addressing mode, if we consider, so one must be memory and other must be register. If you take source operand is memory, then destination operand must be register. If you take destination operand is memory, then source operand must be register. Let us see how we can represent direct addressing mode. See here in this particular, let us see example once. I'm writing like this: move AL comma box of 5000H. So let us see what the meaning of box indicates. So box indicate it is now act like a address. So my register AL receiving an 8-bit data from the memory location 5000H. For example, 5000H memory location having one 8-bit data. Now that particular data is now transferred to AL register. So in this particular example, 5000H is memory whereas AL is register. So the source operand is memory whereas destination operand is register. If you see other example, move box of 3000H comma A. Example, what happens? The register AL sending its 8-bit data to memory location 3000H. So in this example, the source operand is register whereas destination operand is memory. Whereas here the source operand is memory whereas destination operand is register. For example, if I am writing like this: move AX comma box of 4000H. So here the size of AX is 16-bit, but each memory location can store only 1 byte of data. If I write move AX comma box of 4000H, then automatically what happens? Indirectly AL takes data from 4000H, whereas AH takes data from 4001H automatically. So if you write move AX comma 4000H, automatically it allocates two locations. 4000H data is moved to AL register, 4001 data is moved to AH register because size of AX is 16 bits. So it required data from two memory locations, 4000 and 4001. Like that, direct addressing mode having one address. That address may be either source operand or destination operand. One must be address, other must be data. That address should be represented with a form of brackets, open bracket followed by closed bracket. Now this is about direct addressing mode. Let us see the other one, register addressing. Let us see what is register addressing. So in register addressing mode, the source operand and destination operand both are registers. So both are registers. Let us see example. We can write like this: move AL, BL. So what the meaning of this instruction? The data that is present in BL is moved to AL register. So here, what is your observation? The registers, but source operand and destination operand both are registers. Let us see another example: move AX, SI. Here the size of SI is 16-bit register, whereas size of AX is also 16-bit register. If you write like this, what happens? So whatever may be the 16-bit data present in SI, that particular data is moved to AX. So finally, what is your observation? The source operand and destination operand both are registers in case of register addressing mode. So in immediate addressing mode, the source operand must be data, whereas direct addressing mode, source operand and the destination operand, one must be address, other must be register. Whereas in register addressing mode, both source operand and destination operand both are registers. Coming to register indirect addressing mode. Name itself, it is also one type of register addressing mode, but we can use one register indirectly. Preferably the source operand and the destination operand, one must be used as a register that should be declared indirectly. Let us see what is indirectly. Generally for indirect addressing mode, preferably we are using SI, DA registers to make as a indirect registers. Okay, SI and DA registers must be used as a indirect registers. Let us see one example we can understand easily. Here I am writing like this: move SI, 3000H, like a immediate addressing mode, same instruction, one type of immediate addressing mode. Then move AL, box of SI. Let us see what the meaning. So instead of taking data directly from 3000H location, we are writing like this. So I am indicating one bracket. Within bracket I am writing one register. Because of this instruction, what happens? My AL register takes 8-bit data from the memory location 3000H. So with the help of, here I am using register SI indirectly. With the help of this register, AL receiving data from 3000H memory location indirectly. So instead of calling memory, here, we are selecting a register. Initially we are loading register with 3000H. So what is the meaning of this instruction? My AL receiving 8-bit data from 3000H location. 3000H location with the help of SI register. SI. Okay, this type of addressing mode is called as register indirect. Indirectly, we are accessing data through register from memory. Let us see other way also we can write same examples. Here, move box of SI, A. So in this example, what happens? In first example, the indirect register must be source operand, whereas in this example, the indirect register must be destination operand. Here, whatever it may be the data that is present in AL register, the data will be moved to 3000H memory location through SI. So finally 3000H memory location receiving data from 8-bit. Okay, so here one must be register, other must be register used indirectly. It may be either source operand side or destination operand side. Coming into next one, a register relative addressing mode. Okay, it's like a register addressing mode only, but here we are adding 8-bit or 16-bit address to indirect register. Okay, so remember here in register relative addressing mode, the overall address should be the address of index register plus 8-bit or 16-bit address. Okay, through example we can understand easily. Let us see here. I'm writing move AL, comma SI plus 20H. What is the meaning of this instruction? So AL takes data from a memory location and it's a combination of SI address and 20H address. For example, SI is 3000. So 3000H data address is now added to 20H address. What is the overall address now? Overall address is 3020. So your now in this particular example, the register AL takes data from 3020H location. So here we are adding 8-bit relative address to the existing indirect register address. So already SI is equal to 3000. So 3000 is now added to 20 with new address, that is 3020H. From the address AL takes data. We can write reverse also. Same address we can as a destination operand. This one we can select like a source operand. So in this example, AL takes data from 3020. If you write reversely, so 3020H memory location receiving data from AL, like that also we can write. So here finally we have X means indirect address is now added. No, total indirect address contains index address plus 8-bit or 16-bit address. So if it is a 16-bit, let us say how we get to move a box of DI. Not only SI, we can make it DI also. DI plus 2000H comma AL. So what is the meaning? Already, for example, assume DI is 3000. Then 3000 data is now 3000 address is now added H address. So your 5000H address receiving AL data. So AL having 8-bit data. The data is now moved to 5000H memory location. Okay. So here two addresses are present. Okay, 8-bit or 16-bit address plus index register address both are present. Okay. Now coming to base addressing mode. It's like a register related addressing mode only. Here it's like same way. Here we have two indirect addresses. One is the register BX can be used as one address for indirect address generation, and similarly SI or DI. Okay, so BX and SI or DI. So total two registers must be present as indirect registers in base index addressing mode. Let us say example move AL, comma box of SI plus DI also we can write, or box of BX, box of BX. So one must be index register, other must be base register. So what is the meaning of this particular instruction? So AL takes data from the memory location SI plus BX. For example, SI is 3000, BX is for example 3000. So my AL takes data from 6000H memory location. Okay, it's like a previous register relative only, but here we are adding 8-bit or 16-bit relative address directly, whereas here we are adding BX register. Okay, that is present in BX is now added to SI. So BX is now act like a one address, S is act like another address. We get overall address. From that address, AL takes data. Okay. Here also these two indirect registers may be in the source operand side or destination operand side. Okay, right. So finally, register relative, then relative means 8-bit or 16-bit, then base register. All are act like a index addressing mode. So same. Now in previous two addressing modes, we have two only. Two are present in the indirect portion, either SI or 8-bit, SI or DI, or 8-bit or 16-bit, whereas SI or DI and BX. Whereas here SI or DI, any one from SI or DI, then BX, then 8-bit or 16-bit relative address. So you see the example, it's very simple. Here move AL, comma box of SI, box of BX, then 20H. So in this particular example, AL takes data from sum of SI plus BX plus 20. So total will be the new address. For example, SI is having 3000, BX is having 3000, then 20. So put together 6020H is the new address. From that address, AL takes 8-bit data. So here total one is 8-bit or 16-bit relative address, base address, and index addressing mode. That's why put together it's called it as a register, relative, base, indexed addressing mode. So these three must be present either in the source operand side or destination operand. We can write reverse also. Destination operand side also we can write. Like that we have addressing modes. Let us see finally. So immediate addressing mode, in this particular addressing mode, the source operand must be either 8-bit data or 16-bit data. Destination operand must be registered. Okay, so syntax for any addressing mode is move destination operand comma source operand. Whereas in direct addressing mode, the source operand and destination operand, one must be memory, other must be register. Okay, so memory can be represented in the form of a square bracket. So memory, for example, memory is in the source operand side, register must be destination. For example, memory in the destination operand side, the source must be registered. In case of addressing mode, the source operand and destination operand both are registers. Whereas register indirect addressing mode, so here we are taking processor can access the data from the address through indirect register, or processor can send data to an address through indirect register. See the example, move AL comma box of SI. So in this case, AL takes data from 3000H memory location through SI register. So similarly, in this example, AL sending its 8-bit data to memory location of 3000H through SI register, but used SI register indirectly. Then other is register related addressing mode, means here index addressing mode, index registers like SI or DI added to 8-bit or 16-bit address. Okay, then total address should be the sum of index address plus 8-bit address. So in this example, 3000H and 3020H data that is present in 3020H will taken care by AL. Reverse also possible. Base indexed means base register and index register both are act like a indirect registers like SI and BX. So AL takes data sum of base index addressing mode, means they are adding base added, index address added, 8-bit or 16-bit address will added. Total address would be sum of SI plus BX plus 8-bit address, 820H or some other also. That is a new address. From that address, the data that is present in this particular total address is sent to AL register. Like that, we can analyze addressing mode.